Concrete pavements are designed to perform for decades under harsh service conditions. With recent advancements in testing technologies, it is now possible to ensure durability of concrete pavements by specifying and designing concrete mixtures for quality to resist environmental and loading impacts, controlling quality during construction by undertaking the proper quality control actions during concrete placement, and incorporating new testing technologies as part of agency acceptance following construction to ascertain that the concrete meets or exceeds specification requirements. Specifying and designing concrete mixtures to resist environmental and loading impacts entails focusing on things that matter for performance. This necessitates an understanding of what makes concrete last based on failure mechanisms observed in the field and seeing that the designed mixtures address those failure mechanisms at a desired level of reliability. Focusing on performance involves moving away from prescriptive specifications and toward a performance-driven quality assurance specification and acceptance program. Critical properties of concrete that address potential failure mechanisms include tests for strength, shrinkage, freeze-thaw resistance, transport properties, aggregate stability, and workability. The specified test should be able to measure critical performance criteria, be completed economically and rapidly in the lab or the field, allow innovation while evaluating the performance that matters. A number of tests that meet these criteria are included in AASHTO PP 84, which is a guide specification that includes tests completed either during mixture design or at placement or both. The tests included in PP 84 relate to durability characteristics of the concrete mixtures, and the tests are flexible enough to allow highway agencies to pick and choose the tests that are most suitable for them. Moving forward with this approach encourages agencies to measure the properties that relate to durability rather than relying on slump, strength, and total air to assess their concrete.
There are a lot of tests that you could run for durability. So I'm going to just talk about two that are very field-friendly and two tests that are actually being used by a lot of DOTs right now, being evaluated right now. Of course, those are the super air meter and the surface resistivity test.
The surface resistivity test is used to evaluate the electrical resistivity of water-saturated concrete to provide an indication of the concrete's resistance to chloride ion penetration.
The surface resistivity meter basically has 4 probes on it. The outer probes apply voltage and the inner probes apply measure current. And using Ohm's law, we could measure resistance. And from resistance, we can calculate resistivity.
Checking the concrete's permeability is very important during mixture design and during construction of highways and bridges. Traditional tests can take more than 2 days to complete, but the surface resistivity test takes less than 5 minutes to take readings, which saves time and money for agencies and contractors.
There are no chemicals involved. And the other big advantage with this is it's non-destructive. You can run this particular test on everyday sample to just check and see how consistent the mix is. The second big advantage with this is surface resistivity test can be used as part of the formation factor concept, which basically gives us information on how durable concrete is.
The super air meter is a device that measures the air void system under a series of pressures. The data collected can predict air system quality and freeze-thaw performance data.
SAM is basically giving us information on how durable our concrete is from a freeze-thaw standpoint. If your concrete is experiencing a lot of freezing and thawing, especially in the northern climates, what happens is the water within the concrete wants to expand, and when it wants to expand, it expands by 11% or so.
The testing procedure calls for running the test several times without releasing the pressure from the bottom bowl and provide data under increasing air pressure.
If you have tiny bubbles evenly spaced throughout the concrete, the first line and the second line will be very close to each other. If they are too far apart, then that particular concrete is not good from a freeze-thaw standpoint.
The super air meter and surface resistivity test measure durability in a much shorter time frame based on performance indicators to predict how durable concrete is or how long the concrete could potentially last. In a performance-driven quality assurance specification, the burden is on the contractor to deliver the concrete mixtures as specified by the agency. As such, the contractor's quality control process plays a key role in ensuring quality of the concrete mixtures. Agencies should require contractors to provide and adhere to an approved quality control plan, which includes quality control testing during construction to monitor and control quality for mixture properties such as unit weight, air content or SAM number, water content, formation factor or surface resistivity, and strength. Regardless of the test a contractor performs, engineering concrete mixtures for performance provides a contractor the flexibility to innovate and use new materials, methods, and technologies, as long as they deliver an end product that meets the agency specifications. Ultimately, it is the agency's role to test the concrete mixture as part of the acceptance process following construction. Engineering concrete mixtures for performance entails agencies making changes to their specifications and only test for properties that impact performance as outlined in AASHTO PP 84, while de-emphasizing properties that do not impact performance. Examples of potential changes to specifications include eliminating the slump test because it does not correlate to durability, removing minimum cementitious content requirements, and relying on the contractor to proportion and design the mixture to meet agency testing requirements. Removing single aggregate gradation requirements because gradation of the aggregate blend rather than that of a single aggregate is the key factor that impacts performance. Ensuring durability of concrete and long life of concrete pavements involves the three-pronged approach of properly specifying, controlling, and testing concrete mixtures. Agencies can achieve this by only specifying tests that impact performance while eliminating requirements that do not impact performance, thus providing flexibility for a contractor to innovate. To learn more about engineering concrete mixtures for performance, visit us online at FHWA.dot.gov/pavement.